So in this video, we're going to draw the Lewis structure of water and kind of explain why water is polar. And you could actually certainly use this video and apply to every single Lewis structure you'll actually see in General Chemistry 1 and 2. So how I draw my Lewis structure is, again, I identify my atoms. So in water, I have one oxygen and I have two hydrogens. Now, how many valence electrons does each of these atoms have? Well, we know oxygen has 6 valence electrons, and if you don't know how we're coming up with this, then I have a couple of videos on the channel that explains how we actually come up with the valence electrons from the periodic table. We know that hydrogen also has 1 valence electron, and we have 2 hydrogens, so we also have another valence electron. So my total valence electrons that I should place in my Lewis structure should be 6 plus 2. So total, I have 8 electrons to place. All right, so usually, again, the first atom in the molecular formula, in this case, it's H2O. The first atom is typically your central atom. But remember that H2O or water is an exception in that hydrogen can never be your central atom simply because it only has 1 valence electron. That means it can only form 1 bond. So by default, oxygen therefore will be our central atom. And at this point, I'm just going to place 2 hydrogens around my oxygen. Now, I always start from the ground and build up. So what does that mean? I start with 1 single bond, and then I move to a double bond, and then I move to a triple bond. So I do not immediately start my Lewis structures with triple bonds. You can, but it becomes a little bit more cumbersome because remember, there's no really direct, strict ways of drawing Lewis structures. It's all about practicing, right? So in this case, I know that I could form a single bond between the oxygen on the left, between the oxygen and the hydrogen on the left, and also could form the same thing on the right side. So total thus far, we have 2, 4, because we have 2 single bonds, or 2 pairs of single bonds. I'm sorry, or 2 single bonds, and each single bond counts as 2 electrons. So therefore, because we have 2 electrons, we've placed 4 electrons thus far. Now remember, we cannot really place any more electrons around the hydrogen because hydrogen only has 1 valence electron, therefore it can form 1 bond, and it's maximized. So hydrogen will never satisfy the octet rule. All right, so we have 4 more electrons in place, and the only place we could actually put these are actually on the oxygen in the form of lone pairs. All right, so we have 2, 4. So total, how many electrons we have in our Lewis structures? 2, 4, 6, 8. Right, and so the number corresponds, so we know that we're in a good range. So this is a plausible Lewis structure for water. Now, how do we determine if it's polar or not? We use what we call dipole moments. And this side of the arrow just simply means that the atom of interest is losing electrons, so it becomes a little bit more positive, whereas the arrow itself, the arrowhead, just represents a net negative charge. So the atom of interest is gaining electrons. So in this case, we want to draw dipole moments. And so in this case, I could use a dipole arrow signifying the electrons going from the hydrogen to the oxygen simply because oxygen is more electronegative. That just means it's hogging the electron. So hydrogen gains a slightly more positive charge, and the oxygen gains a slightly more negative charge. The same is true on the opposite side. Right? The same is true on the opposite side. Now, anytime you have dipoles going in the opposite direction, where the arrows are tail to tail like this, that just means they cancel out, right? So that means there's no net dipole moment. In this case, they're actually going head on. That means the arrows are pointing in the same direction. But what I want you to keep in mind is that something very interesting occurs. Because you have these pairs of lone pairs on the oxygen, what it actually does, it actually bends down the single bonds. So the real correct way of drawing the Lewis structure of water would be something like this. Because of the pairs of lone pairs, it actually bends, it actually decreases the bond angles. So it is not as linear as we drew it initially. And if we replace our dipoles, you could see this is the more plausible Lewis structure for H2O. So just please keep in mind, anytime you see pairs of lone pairs on a central atom, the bond angles are going to decrease. So they're going to be bent a little bit further down. And this explains why water is polar, right? So had we had the dipoles going in directions like these, then we could have said, okay, well, this is a net zero, so therefore therefore the molecule will be non-polar. First of all, they're going in the opposite direction, so they're head-on. But the real Lewis structure, or the correct way of drawing the Lewis structure of water, would be this version, because the lone pairs actually bend down or decrease the bond angles, and this is what makes the molecule polar. So your dipole moments do not cancel out in this case.